rays and so on drop out.
It is the end for life in the oceans as we know it. Whales, dolphins, jellyfish, coral reefs, pretty much everything. All gone, unable to survive in the increasing saltiness of the water.
And at some point you're left with brine flies, a few little worms, and some of the microbes that you see here. And at the very highest salt concentrations, about 10 times the salinity of the ocean, you only end up with organisms called halophile.
It is the halophiles, tiny organisms that thrive in high salt environments, that give the water its red color. This color is no accident.
Now, during the summer, we tend to get tanned. I've been in the pool, I look a little tanner than I would in the winter. Well, these organisms also have to protect themselves from a very strong sun, ultraviolet radiation. And so instead of tanning, they tend to produce a lot of red pigments, carotenoids. These are the same kind of compounds that you see in tomatoes and carrots and so on. And this orangey red pigment helps protect these organisms from the very high sunlight.
With a blazing sun filling the sky and temperatures rising, only these incredible survivors called extremophiles can take it. 1.2 billion years from now, all other life is gone.
As the Earth becomes a very hostile place, we're back to having a world that's only populated by microbes, very much the way it was during the early evolution of life on Earth.
Extremophiles clinging on at the ragged edge of survival in the last remnants of the ocean. The final hammer blow that will end all life is now just around the corner. 1.2 billion years from now, plants and animals have been wiped from the surface of the Earth. Only microbial extremophiles survive in a rapidly evaporating, increasingly salty ocean. For the oceans, time has finally run out. The brightness of the expanding sun boosts average global temperatures to a blistering 100 degrees, nearly double than today. Professor James Casting is investigating the devastating effect this has on the oceans of the future.
Well, we think that the Earth will start to lose its oceans when the sun gets about 10% brighter than it is today.
His findings confirm evidence gathered by Apollo astronauts in 1972. Hydrogen is escaping from the Earth. Water is made up of 1 part oxygen and 2 parts hydrogen. So what the astronauts were seeing was the infinitesimal loss of the oceans into space. Today, this amount is nothing serious, but 1.2 billion years in the future, when the temperature is 100 degrees, the process goes into overdrive. Faster evaporation now saturates the air with water. As this water rises to the top of the atmosphere, ultraviolet light from the sun splits it into its 2 component parts, oxygen and hydrogen. The hydrogen is so light, it floats off into space, lost forever. The gradual loss of the oceans also creates a new and terrifying sky. A sky that will slowly begin to obscure the sun. From space, the surface will seem to disappear.
I think if we were able to observe the Earth, say from the moon, 1 billion years from now, when it starts to lose its water, we'd see a planet that looks very different from today.
As more and more hydrogen is lost, the increasing amount of oxygen is getting thicker, and the evaporation rate is making the atmosphere more and more dense. Humidity is now at 100%. Thunderheads will rise higher. At 60 miles high, the roiling heat and moisture now begins to create superstorms, more violent and powerful than we have ever seen before. Because of the vast quantities of water being dragged up from the surface, ice will form in the upper atmosphere. Giant hailstorms will rage. But because of the heat below, none of it will ever reach the ground.
You'd see this very gaseous atmosphere. You probably might not be able to see the surface. And if you were able to look in the ultraviolet, you'd see lots of hydrogen escaping to space. So it would be a process that one could see, and you know that something very bad was happening on the planet's surface.
It's a deadly cycle. The hotter it gets, the faster our oceans are lost, and the more violent the skies become. It's what scientists call a greenhouse effect. What casting discovered was that from full to empty, the whole process of losing our oceans could take less than 200 million years. Without water, life cannot exist. So to find out when this will happen, he had to look at a planet not unlike the Earth that lost its oceans in the same way.
Well, I got interested in the future of Earth's oceans by working not on Earth, but on Venus.
Physically, Venus is almost a twin of our planet. And billions of years ago, it might have been even more similar. Studying Venus helped casting estimate when we will start to lose our oceans. The answer came as a shock.
Well, up until we had worked on this problem, many scientists thought that the Earth would retain its oceans for at least another 3 or 4 billion years. But we were able to show that bad things start to happen much earlier than that. The oceans could be lost in 1.2 billion years.
With the water gone, dry salt crusts like these are all that will remain of the Earth's magnificent oceans. Is this the end for life? Incredibly, a new discovery has shown that even without water, basic life forms can survive. But for how long?
Although we'd known that organisms could live in very high salt, we knew that they could also be trapped in solid salt. But what we didn't know is that while they're in the solid salt, it's more than them being in suspended animation, that they are actually still metabolically active. They're still breathing and eating and excreting and doing all the sorts of things they need to do, but at a very, very, very slow rate. So that was really an astounding discovery for us.
In 1.4 billion years, with the oceans finally gone, extremophiles will survive in the solid salt, but just barely.
These organisms will be able to survive a good deal longer in a salt crust like this, even in the absence of water. They won't be able to survive forever like that, but it'll buy them a little time.
Perhaps another few million years. In that time, their main protection will be the red color that acts as a sunblock. While they live, they will transform the way